So I am going to share the first page today. This is what I am saying. These are those formulae of which you know the first formula very well. The sum of the first n natural numbers is equal to n into n plus 1 by 2. It comes from the sum of n terms of an AP is equal to n by 2 times first term plus last term. So here first term is 1 and last term is n. So sum of the n terms is equal to n by 2 into 1 plus n. So this is well known formula which is written in this form. We remember the formula in this form. Two more formulae are there. Sum of the squares of first n natural numbers is given by n into n plus 1 into 2n plus 1 6 divided by 6, and 1 cube plus 2 cube plus 3 cube plus and so on n cube is equal to n into n plus 1 by 2 whole square. Let us see verification. For example, if we add first three numbers, first three terms, 1 square, 2 square, 3 square, according to the left hand side. If we add this by actually solving, it is 1 plus 4 plus 9. This is equal to 14. And so, right hand side, if we use the formula, we will put n equal to 3. We will put n equal to 3. So that way, 3 into 3 plus 1 multiply by 2 times 3, that is 6 plus 1 divided by 6. Now this is 3 2s are 6. This is 4 into 7 28 divided by 2, which is also 40. So in this way, this formula is true for all natural numbers n. Let us take the verification of this last formula also. Suppose we take the three terms 1 cube plus 2 cube plus 3 cube. This is left hand side. If we solve as such, it is 1 plus 8 plus 27. This is equal to 36, which is actually 6 square. And what is 6? The sum of the first three natural numbers as such, if we take, this is 6. So it is 6 square. This is a very good property of natural numbers. If you want to add the cubes of first, say, 4 natural numbers, then you simply add those natural numbers and do the square. This is 10 square, this is 100. Okay? So you have to remember these formulae. These will be used in the things we are doing now. So can I proceed? Next page. Yes.
Sir, yes.
So next I am going to do the same thing we were doing yesterday. This is the curve, blue color curve, y is equal to x square. This is x axis. This is y axis. The values of x are taken here 1, 2, 3 like this. The values of y are taken here 1, 2, 3, 4, 5 this way. If we have x equal to 1, y is equal to 1 square. So we have for x equal to 1, y equal to 1, we have the point here. If we take x equal to 2, y is equal to 2 square, that is equal to 4. So if x is equal to 2, y is equal to 4. So we have drawn the curve, and in particular if x is equal to 0, y is 0. 0 square, that is 0. So 0, 0 point, this origin already there. So we have drawn through these points a curve. This is the graph of the equation y equal to x square. Now along the x-axis, the spread of this graph or the projection of this graph is from 0 to 2. That length is equal to 2. 2 minus 0. The length of this projection or the spread of the graph along the x-axis is 2. We have made n equal parts of this. Each equal part is of width h. So we are erecting the rectangles on each small part which is of width h. So we have made n rectangles below this curve on the x-axis. Now for the first rectangle, x is equal to 0. For the second rectangle, x will be h. For the third rectangle, x will be equal to 2h. This way, the values of x are forming an AP 0, h, 2h, and so on. Intermediate term, kth term of this AP will be k minus 1h. And the last term of this AP, that is the nth rectangle, x value will be n minus 1 times h. So for the general value, general term has this value of the x coordinate here, this value. This is k minus 1 h. And we want to find the height of this rectangle, that will be given by the y coordinate. And y coordinate is related with x coordinate by this equation. So y coordinate is equal to k minus 1 h whole square. We can write k minus 1 whole square into h square, which can be simplified like k square minus 2k plus 1 into h square. Now the sum of the areas, we come to the main part of the calculation. Sum of areas, first rectangle's area, width h, but height is, if you put k equal to 1 here, k 1, so 1 square is 1, minus 2 into 1, so 1 minus 2 plus 1, this is 0. So 0 into h square is, the first rectangle's area is 0. 0 times h square you can say. Second rectangle's k2, 2 square is 2, minus 2k. Actually what we do, yesterday also, we made the three parts separate. 1 square, first term I am writing, k is equal to 1. This is the width of the rectangle, and I am writing the height of the first rectangle. So width of all the rectangles is same, so I have taken common. So height of the first rectangle is 1 square minus 2 times 1 plus 1 into h square. Height of the second rectangle, it will be 2 square minus 2 times 2 plus 1 times h square. Like this up to nth rectangle. So k will be taken equal to n. So n square minus 2n plus 1 times h square. This is equal to all terms contains common quantity h square also. So h square is also taken common. H into h square becomes h cube. Now I add the three kind of numbers separately. Square numbers I add separately. 1 square plus 2 square plus up to n square. Then the terms which contain no square but variable like 1, 2 and so on n. Minus 2 is common among them. So we are taking minus 2 common. We are left with the sum 1 plus 2 plus up to n plus now 1 plus 1 plus and so on 1. How many ones are there? They are n in number. They are the same constant values. So I write here n terms. Is this much clear?
Sir, yes.
Sir, yes.
So what we have obtained is the area of all these rectangles. Like I can show this like this, something like this you can say. But each rectangle has a top which is made by two straight sides and one part of the curve. That those areas are not included. So it is not exactly equal to the area under the curve yet. But whatever it is the area of all the rectangles. We will simplify it now. We simplify it. This is equal to h cube multiplied by the sum of the squares. I gave the formula n into n plus 1 into 2n plus 1 divided by 6. Then minus 2 times sum of the first n natural numbers. This is n into n plus 1 by 2, you know. And sum of 1, 1, 1 and so on n times. This is simply n. 2 cancels here. This is h cube multiplied by n into n plus 1 into 2n plus 1 divided by 6. If we solve this bracket, minus n square minus n square minus n plus n, so that n and minus n also cancel. Is the calculation clear up to this point? Yes. So we will
Sir,
be
yes.
using the concept n into h equal to 2. We will form as many n times h as possible to make the calculation very easy. nh is equal to 2. We will use this. So I am going to the next page so that I can do the calculations. So we have the area equal to h cube multiplied by n into n plus 1 into 2n plus 1 divided by 6 and minus n square. This was left. I multiply h cube inside. H cube goes into 3 parts nh. So 1h I multiply here, 1h inside this bracket, so nh plus h, and 1h I take into the third bracket. So this is 2n plus h divided by 6. Now with the n square, I can adjust h square. I can write nh whole square. 1h is left, I multiply here. So this is equal to nh is 2, 2 into 2 plus h plus 2 here also nh. So 2 times nh matlab 2 times 2 plus h divided by 6 minus here 2 square into h. Now when number of rectangles is made equal to infinitely large, the width of each rectangle will become 0. Then area under the curve exactly found, area under the curve is equal to 2 into this, h will become 0, 2 into 2. So here not plus is there, sorry. Here is the multiplication. So into 4 plus 0, that is 4, and divided by 6. And this is 4 times 0, so this is 0. So this is 1, 2 cancels. Answer is 8 by 3. So this is the exact area under the curve. Got it clear? Yes. Yes, Samraj. Arpan. Yes. Gurkirat. Gurman.
Yes, sir.
Jasmeet.
Yes, sir.
So if anybody has not understood and you are not able to say, if your voice is not coming to me, you can use the chat box also. Now I am going to the next problem. I stop sharing and open the next page. Just I am doing, wait for some time. I will be calculating similarly the area under another curve. The curve is y is equal to x cube. Y is equal to x cube. I am just going to open the page. I am going to share. So here is our curve. Y is equal to x cube. So when x is equal to 0, here x is 0, y is equal to 0 cube, which is 0. So y is also 0. If we take x equal to 1, y is equal to 1 cube, which is 1. So I have this point 1 comma 1. X is 1, y equal to 1. When I take x equal to 2, y is equal to 2 cube, that is 8. So we have this point 2 comma 8. 1, 2, 3, 4, 5, 6, 7, 8. So 2 comma 8, this point. I have made a curve passing through these 3 points. We have to find the area beginning from origin up to x equal to 2. So we have the width 2 minus 0 equal to 2. We make n equal parts. Each part has the width h. So the values of x will be similarly beginning with 0, then next h, then 2h. Intermediate value will be general term of this AP. the general term will be x equal to k minus 1 times h, and the last term will be, because we have n terms, so it will be n minus 1 times h. And here is this point. I have taken x coordinate for this point equal to k minus 1 h. This very rectangle's height y will be given by x cube formula. So this is k minus 1 cube into h cube. That is equal to k cube minus 3k square minus 3k, not minus 3k, plus 3k and minus 1. This is how whole cube totally expands into h cube. Now I write the main part of the calculation begins. Sum of areas of rectangles. These n rectangles. So that is equal to, for the first rectangle, the width of all the rectangles is h. We multiply and take it common. The height of the first rectangle is k1 taken, 1 cube minus 3 times 1 square plus 3 times 1 minus 1 into h cube. Second term, that is the height of the second rectangle, 2 cube minus 3 times 2 square plus 3 times 2 minus 1 into h cube plus and so on. Last term will be n cube minus 3n square plus 3n minus 1 into h cube. So what we do the same thing. We add, actually take h cube also common. So h power 4 will be outside. We add the cube terms separately. Up 1 cube to n cube. Then minus 3 times square terms separately up to n square. Then plus 3 times sum of first n natural numbers up to n. And minus sum of n ones. So this is h power 4 into the first formula. I have the sum of the cubes. I have told you it is n into n plus 1 divided by 2 whole square. Sum of the squares we have already used. N into n plus 1 into 2n plus 1 divided by 6. So here then plus 3 times and so 3 times sum of the first n natural number. This is n into n plus 1 divided by 2 and minus n. So this is what we have to solve. So I will be going to the next page. Up to this, the calculation is clear. Yes, Man, are you there, Man? Yes. So I am going to the next page. I am writing the same expression here. h power 4, the square of n into n plus 1 by 2 can be written as n square into n plus 1 whole square divided by 4 minus 3 times n into n plus 1 into 2n plus 1 divided by 6 plus 3 times n into n plus 1 by 2 and minus n. One step more and then I will take h power 4 inside. N square can be written as n into n plus 1 square can be written as n plus 1 into n plus 1 divided by 4. Here 3 cancels. It is simply n into n plus 1 into 2n plus 1 divided by 2. This is 3 by 2 n into n plus 1 minus n. Now I multiply h power 4 inside. These are 4 terms. I multiply one h with each n. nh into nh. One h is multiplied in the bracket, so nh plus h. Here also nh plus h divided by 4. Here I have 3 terms to adjust, 3h. nh multiply by nh plus h multiply by 2 nh plus h divided by 2 into h. Here I have only 2h to be adjusted, nh into nh plus 1 h multiply by h square and last term nh into h cube. Now this is the time to put the value of nh. 2 was equal to h was equal to 2 by n, so nh is equal to 2. This is equal to 2 into 2 into 2 plus h into 2 plus h divided by 4 minus 2 into 2 plus h into 2 into 2, that is 4 plus h into h divided by 2. This 2 cancels here. Then 3 by 2 into 2 into 2 plus h into h square and minus 2 times h cube. Now as n tend to infinity, h approaches to 0. Here because 0 alone is there, 0 square is there, 0 cube is there, all these terms will become 0. Only this term will give you the answer. 2 2s are 4 and 2 plus 0 into 2 plus 0, that means the answer will be equal to 4. So I hope this is clear.
Sir, yes.
So this is the maximum difficulty we have reached. This method I am explaining is actually the method of finding the integral by the basic principle or the fundamental principle. So this is actually a long method, but now tomorrow onwards I will be introducing the concept of derivatives. Much easier concept, and then I will introduce that concept which will make this kind of problems easier. So this part is also there in the syllabus. If maths is concerned, that is +2, but derivatives and the technique of finding this kind of areas using the techniques of derivatives, and that we will be doing tomorrow onwards. Okay. Arpan, this is what we are doing, area under curve. Yesterday also I told, in maths, this is in calculus, but in physics also, this part in calculus, I am explaining it now in this way. In physics, you will be studying using these things earlier than we do in maths. So that's why I am trying to give you the overview of such things which will be used in physics. So tomorrow onwards, I will be giving you those techniques which helps to solve these problems, which I have explained actually basic things, but now I will give you higher formulae. I will explain the better formulae for doing these things in an easier way. So we will be beginning with limits and derivatives. Limits and derivatives. This is a chapter in maths in +1, and also this is useful for physics, not only because this kind of problems will be done easy way, but also there are other uses of this limits and derivatives. So we will be beginning tomorrow limits and derivatives, and actually what I have done was the concept which is linked with the limits. Actually, it is linked with the area under the curve, which is studied in maths, in calculus, and used in physics. Okay.
Sir, yes.
So I leave the class now. Okay.